Hi guys, we're about to start on time. So my name is Svetlin Nikolaev and I'm leading the UX and product design for DevTools in Progress Telerik. As you already knew, our history is long of providing components and products to developers for various channels and in various flavors. So naturally, we are turning our heads into VR and augmented reality as next channels for content distribution. In today's session, we will cover a few topics, starting with the comfort zones for augmented and virtual reality, interface patterns, typography, some of the best practices as we know of them for now, and the evolution of these two technologies. Augmented and virtual reality are believed to be the next main channel for content distribution, for gaming, and for general user experience. So they will become the preferred way for people to communicate, to collaborate with each other, to ingest content, to play games, and interact. And that is so important that we will need to nail the user experience for these channels. Augmented reality applications are really just emerging, and the technology is finding its way in our lives. It's important to understand the interaction within their comfort zones, as it varies from different form factors, different vendors, and different devices. And this is very important for applications that are targeted for getting work done, for productivity apps. For example, for head-mounted AR experiences, these type of experiences are fairly similar to those that you have on a VR headset. But there are a few exceptions, naturally. We need to minimize how much the user are moving their heads, and for how long is the experience taking place. For users' comfort level, we need a rotation of around 30 degrees on the horizontal plane, with a 55 degrees maximum rotation of the head, before starting to get inconvenient. And for the other axis, we are going up 20 degrees and maximum of 40 degrees downwards. And these are the things that are considered comfortable. So when defining the comfort zones for head-mounted experience, AR is important to consider what we are using as a required field of view, and what interactions are required for the users, like gestures, hand tracking, gaze. For example, in mixed reality headsets, they heavily rely on this function of the headset called gaze, when your head movement is tracked by a virtual cursor, and you can point and highlight an object, and then manipulate it with a set of gestures. Virtual reality headsets have another means of controls, like touchpads and joysticks. They very much differ from one vendor to another, but still there are some common practices of usage. And as for a seated AR experience, it is considered comfortable that you place your objects about 60 centimeters from the user and 15 to 25 degrees below the site of vision. And this is forming some very small, comfortable zone to operate in. There is an ideal content area that is basically the intersection between the field of view, the hand recognition frame of the AR device, and the comfortable viewing area that comes from human ergonomics. So each headset is different, but those ergonomic principles apply to all of them. In other means, there is a difference between the experience that you get from a hand-mounted device and those that you get on a mobile AR experience. Mobile AR experiences that rely on holding the device in front of you and using it as a viewfinder when framing your augmented reality content are the basic principles for mobile AR apps. You don't rely here on hand recognition or using gestures, but on some other types of interaction that I'll mention later. Holding the device in this way can be very, very frustrating after a prolonged period of time. So you should be very conscious as developers to provide some time for users to rest their arms and to have the ability to pause the experience and restart it later. So the best practices for augmented and virtual reality interface design are still being defined. There are not many user patterns that are considered to be industry standard, and the designers and developers can rely on. As AR and VR are totally new form factor, and they're very much different from what we've been accustomed to, the 2D interfaces of computer screens, that you have various 2D objects, windows, menus, and you're not utilizing the 3D space at all. When designing for AR UI, you can consider the spatial interface and build it around the user. So you can place a content in real 3D, and this content can also trigger interactions and provide a better and more immersive experience than the conventional 2D screens. This, in fact, is very helpful when you're providing, for example, for business usage, data visualization, and you're trying to manipulate big data sets and view the data from different angles and explore it for some patterns. In AR, you can gracefully avoid hiding content, like using the 3D space, like fading out of content and using the depth of field of the specific device. Also, contextual UI is very popular in augmented and virtual reality. Not like what current computing is using as UI, like icons and 2D shapes to represent different tools. These icons can hide functionality like expandable and hidden menus, and you should try to avoid those patterns when designing for augmented and virtual reality, since the users won't be accustomed to this type of content, and they'll have to learn what this iconography means for them. If the tool is intended to be used in 3D space, you can simply replace those 2D icons with a 3D interface that is in space, and this can give the user purpose of the tooling that you're using. Another big question when working with with AR and VR is how we manipulate and how we present text. The simple rule here is bigger is better. And you should go for something that is legible, something that every viewer can read. So we should go with shorter labels than the bigger one, and we definitely should consider if we have a long form documents that we have to place inside of our VR and AR experiences, how we can handle the columns, the column width. Narrow columns are better than wider ones, as you know from mobile web. And you should definitely consider the legibility when placing text on an AR experience, because you have to make sure that your content is readable on every background. Many AR applications are utility-based, and they sometimes should provide you with a large amount of text. So you have to handle it very carefully and place those texts and provide the text in a contextual way. The AR applications are still defining what makes good or bad practice. So it's often that you, in your line of work, come out with something that is your own assumption, and you should definitely work from here. But you should definitely test what those assumptions are coming to. Are they creating a problem or solving one? So when testing, you should consider large audiences, and you should consider if they can provide you with a sufficient level of confidence if this that you've created is working, or you should go back to the drawing board. One thing that you have to have in mind is to give the same information to your test users as your ordinary standard user will receive, because you won't be there holding their hands when they're experiencing the application by themselves. As you design your app, the other aspect that you consider is the interaction of objects. Most virtual reality interactions use motion controllers, but most AR-enabled and mixed reality headsets use gaze and hand gestures. So you need to keep the experiences within the safety area of those headsets, and you have to prompt and notify the user when they are about to leave this safe area, just to make sure that they're triggering the right commands. And you should make all the interactions as simple as possible. Sorry guys, it's a video and it should be starting, but it's not, so I have to reach out to my computer.
HoloLens is similar to mouse clicks on a desktop. It works in conjunction with HoloLens is similar to mouse clicks on a desktop. It works in conjunction with gaze. A user targets an item with their gaze and then selects or activates the target with a gesture. When a user places their hand in the field of view in the ready position, you get an activation event, indicating that the user is ready for input. A tap is synonymous with a mouse click and can be used to take action on the currently targeted item. You also have a tap and hold gesture, which is similar to holding the mouse button down while moving it. Rotation and zoom are typical uses of this gesture. Gestures are a natural and intuitive way for users to interact with mixed reality content.
Many of the design principles for AR, for both headset and mobile, are the same. However, there is a considerable difference in the interactive functionality. Because of the form factor differences for the devices, they require different rules. Keeping interaction simple and providing feedback to the users is something that is valid for both form factors. But the most interactions in the mobile device are taking place via touch gestures on the device itself, rather than using your hands and the recognition of the AR device to trigger an event in 3D space. Some devices also support voice interaction and have voice capabilities. Although this is not the primary channel to explore when controlling an application, it is definitely something that can be enhanced and can work together with the traditional patterns for user interaction. In this, there are some basic rules that we can follow, and the first one is to use simple commands. That is because you don't know all of your users, are they having accents or dialects, and you should definitely encourage them to take this voice communication control and build it with no learning curve. So very simple commands are useful for them to start learning it. You should definitely enable undo. Whether users are misspelling the command or somebody nearby is triggering the command, definitely you should have the means to go back and reverse the experience. And you should provide feedback to users. So whether your application has received the command, does it understand it, and what is the thing that is happening after this. Coming to some best practices and principles, and starting with giving the users control. In real world, people are always in control of what is happening in them with their current environment. So when people are losing control is when their senses are misaligned, what they see and what is the motion of their bodies. So this condition is referred as a simulator sickness, and this is something that we should definitely avoid when creating our applications. This is the fastest way to draw your users away, and this is something that is basically a rule number one in VR. You want to ensure that the user is feeling in control, and that your every movement and every command that he makes with the headset is mirrored by the environment in virtual reality. Motion in VR is other topic that yet hasn't been solved gracefully. One of the strengths of VR is that it enables you to create very appealing and immersive experiences, and these experiences would be no good if the user cannot move around and explore them. But it's very hard coming from the real environment in VR to understand the boundaries that you have, the physical boundaries. The current devices, you are connected with a cable on most of them. This is soon to be changed, though. And also creating motion in VR when it's not accompanied with real physical motion of the individual creates motion sickness. So one means of overcoming this is using teleportation. You just need to enable hotspots in your application, or by allowing the user to jump from one portion of the VR experience to another. It's a good way to move around the virtual world. And same principles of continuity applies just like in movies. For example, you have to fade in, fade out when jumping from one port to another, not to induce motion sickness. We should always provide user feedback. This is something that is basically universal for all types of interfaces, not only UI in VR and AR. Whether this is haptic feedback, you can use your motion controllers on VR to feedback the user that action had occurred, or combine it with visual and audible cues. In this way, you make sure that this immersive experience gets the maximum of the technology. The last principle is to always avoid simulator sickness. And I cannot stress enough on this. I think that this is something of a general knowledge, that you shouldn't induce such thing on your user. You always should maintain the frame rate of your application. Do not drop below a certain level that is standard for gaming and media experience. Also, you should always keep the continuity of the experience and avoid acceleration. Facebook and Oculus are heavily betting on VR as the next media and gaming platform. They are spinning their next creation in the beginning of next year. And it is believed to revolutionize the VR experience for the masses, as they're cutting the cords and they're providing a very affordable experience in a standalone device.
It's just you and your hands, completely free and immersed. With 6 degrees of freedom, state-of-the-art optics, and built-in audio. You can forget about wires, PCs, and phones. Oculus Quest is ready to play when you are. The headset relies on 4 ultra-wide-angle sensors to map your environment as you navigate through it. And with Oculus Insight tracking, every move you make in the real world translates right into the game you're playing. Combine that with Oculus Touch controllers, and the game is at your fingertips. So when you grab, swing, or cast a spell, you'll feel the power of every gesture. The next level of VR gaming is finally here.
Apple, Adobe, and Pixar, on the other hand, are betting heavily on AR as the next medium for content delivery and immersive experiences. They believe that AR would be such channel because nearly everybody has an AR-enabled device in their pockets.
In my toes and in my shoulders, I've been shaking like I'm colder. In my head, in my eyes, feels like I'm never getting older. My heart on my sleeve. shorts down the night.
So with their new file format, the Universal Scene Description file, or USDZ for short, they're trying to combine 3D scene in a single file that can be easily shared. This file can contain all of the scene parameters, objects in it, animations, behaviors, and basically all properties for VR static experience, AR static experience, sorry. Designers and developers will be provided with the tools that can create such experiences, and Adobe announced the first iteration of those tools this year, enabling Photoshop, Illustrator, and Dimensions to produce 3D content that they can later distribute via their project Aero for mobile and via USDZ file for web. This early iteration of the products are still very limited to static 3D billboards with annotations, built-in interaction behaviors and animations, but they have many features in the pipeline, and they'll create for the creative professionals unprecedented tools for creating zero-code AR experiences. Where are we going, and how deep would this technology affect our day-to-day experience is questions that are soon to be answered. The rapid evolution of technology and the adoption of those technologies in a consumer level projects that augmented and virtual reality would be definitely a game changer. They're considered to be the next mobile revolution, where the content will be served more naturally to the users and would fuse seamlessly with their physical experience.
See it. Scan. New skin. New subject. Whenever you're ready to begin, just say begin. I'll leave you to it.
I'm listening.
You know that memory crypt that we took out of that stiff?
Yeah.
All right, go 3D. It had an unregistered flight path for a ship called the Anubis. The Anubis left Phoebe Research Station and it was headed for Eros, okay? Now, I'm thinking, maybe something's being transported on this ship. I'm thinking Julie's ship was sent out to intercept it. And then, suddenly, ships start blowing up, the Canterbury, the Donager. It's got to be connected.
We should be very careful, though, of information overload and how we handle the augmentation of all these all this stuff we want to put in our applications. We should be cautious of just not to overdo it.
Great. Nice. Great.
Bastante. Apúrate si quieres una buena calificación.
Voy lo más rápido que puedo.
¿Has pensado en correr? Es saludable y eficiente.
Seguro que no hay más trabajos disponibles. Yo estudié para ser profesora y estoy haciendo mercados.
Y además puedes quedarte con los puntos de fidelización. Eres una amante afortunada. Tienes que confiar en la aplicación. ¿Te sientes inspirada? Gracias. Chao.
¿Quién soy yo? No, eso no es lo que quiero decir. ¿Para dónde voy? No. Puedo volver a empezar. Olvídalo.
Estoy presente ahora. Y veo. Estoy libre de mi ira. Estoy libre de mi tristeza. El amor es mi
This is basically what an augmented reality hell can look like. So, guys, if you're interested in what our plans are for augmented and virtual reality, I have the pleasure to introduce to you the leaders of the VR team in progress, Georgi Atanasov, Panayotsankov, and Dejan Yosifov. Those are the guys that are leading our initiative of providing VR and augmented reality tooling to the developers. And thank you. This is all I have. If you have any questions, you can reach me at the conference or just write me on Twitter. I'll be happy to chat with you. Thanks.